Okay, so let's start. So today we'll solve GATE 2021 question. This is a question from functional analysis. This is a question number 9. So it is saying that let En be an orthonormal basis of a complex Hilbert space H, and consider the following statements. So P is saying that there exists a bounded linear functional f from H to C such that f of En equals to 1 by n. And Q is saying that there exists a boundary linear functional g from H to C such that g of En equals to 1 by square root n. Then four options are given. You have to check which one is correct. Which one is false. So true false you have to check. Okay. So this is the NPTEL reference. So this you can look. Okay, so let's try to solve this one. So what is given first? H is a complex Hilbert space. H be a complex Hilbert space with orthonormal basis En. Right, so these are the orthonormal basis for the Hilbert space. Now what we have to show, we will show that P is true and Q is false, means there exists a boundary linear functional. So we'll show that there exists such a boundary linear functional, and we will show that there does not exist any boundary linear functional G such that of this form. So let first prove for. So for that we need a result for ridge representation theorem. So what is ridge representation theorem? Ridge representation theorem. So it is saying that let f be a bounded linear functional on H, right? Then what it is saying, then ridge representation saying that then there exists unique V belongs to H such that f of x is given by x inner product with V, where x belongs to this Hilbert space H, right? So this is the ridge representation, and this also tells about the norm of f, but here we do not need, so that's why I am not right. So we only need this much. So if f is a bounded linear functional on this Hilbert space, then it will be given by inner product x with B for unique B. Okay, so we'll use this. So let's first prove Q. So now we'll show statement Q is false. Okay, so for that we have to show that there does not exist a bounded linear functional G such that G of, so we have to show there does not exist a bounded linear functional such that boundary linear functional G such that G on the basis elements it will give the value square root 1 by n. So suppose there exists such G. So let's assume so we'll prove this by contradiction. So let's assume there exists a bounded linear functional G such that G of En is 1 by square root n, right? So if G is such a bounded linear functional, then by Ridge representation theorem, what it is saying? Then by Ridge representation theorem, so it is saying that G will be given by G of x will be x inner product V for some V. Okay. And now we know that G of En is 1 by square root n. So therefore, one by square root n equals to G of En, and which is same as En inner product V, right? So this we now get. Okay, now we will use another result, that this is Bessel inequality. Bessel inequality. So it is saying that let En be, oh, I think this will get from itself the Ridge representation theorem. Okay, oh, okay. So, and, so let me write. So Ridge representation will still get the norm of, so and what will extra thing get? That norm of F is given by norm B, right? So this is extra thing also Ridge representation C. So if we use this, then we do not need the Bessel inequality. So we'll use this one. Okay. And norm G will be given by norm V, right? So this is by Ridge representation theorem. Now look at how we can write V, right? So we want to write B. So as ENs are orthonormal basis, so as En are orthonormal basis, so you can write V equals to V inner product En, so summation n belongs to n, V or n inner product B or V inner product En, right? So this we can write. So therefore the norm of V, so as Ens are orthonormal, so if you calculate the norm V, what you will get? You will get basically this. Norm V square will be summation n belongs to n. Using the orthogonality, you will get this En comma V mod square. So this is the norm V. Now look at what is this, and also we have got that this is the, so this is for all n, right? For all n belongs to n. So you have got that En inner product B is also given by this if such a G exists. So let me call it 1 and let me call it 2. Then from 1 and 2, we get, so putting that En inner product B is 1 by square root n, this sum is norm V square. N belongs to n, 1 by n, so this is norm V square. And what is this? But this is a harmonic series. We know that this series diverges. But norm V, this is a norm of a particular element. So this is finite. So what is this? Summation n equals to 1 to n, 1 to infinity 1 by n equals to norm V square. So which imply as norm V is finite, so which is a contradiction. Which is a contradiction. Because this series diverges. So why we arrive at a contradiction? Because we have assumed that there exists such a bounded linear functional for which it is given by this. So means there does not exist any bounded linear functional which is given by this. So there does not exist any bounded linear functional G such that G of En is given by 1 by square root n. Okay. So we have done with statement Q. Now we will show that statement P is true, means such a bounded linear functional exists. Okay. Now we will show statement P is true. Means what we will show? There exists a bounded linear functional f from H to C such that it is given by f of En equals to 1 by n. So we have to construct a bounded linear functional which gives at the vector En, it will give the value 1 by n. So how to construct such a bounded linear function? So let's see. So we have to define. So we have to define f from H to C f of x, right? We have to define. So how to define? So x, let x is in H, and we know ENs are orthonormal basis, which implies x you can write as x inner product En, right? N belongs to natural number. Why this you can write as ENs are orthonormal basis. Right. Now we want a bounded linear function, right? So f should be linear. So as we want f to be linear, so f of x should be given by, so this is a scalar, so it will be f(en), right? So f should be of this form if such a function, linear function are given. And what we know, f of en we need, so this to be n belongs to 1 n x en 1 by n, right? So basically this is summation n belongs to n 1 by n x en. So this should be the definition if such a bounded linear function. Okay, so we'll show that indeed this is a bounded linear function. So we will show that. So let's define. So define f from H to C such that f of x and n belongs to n. Okay, so we have defined like this, but why this makes sense? Why this is finite, right? We have to check because this should be an element of C. So let's check, and we need also that, so linearity is not a problem, and we have to also that this is a bounded linear function, right? Okay, so let's check. So then what is mod of fx? So this is less than summation n belongs to n mod of x en. So this is 1 by n mod of x en. Now use Cauchy-Schwarz. So take this to be 1 and this to be an and bn, and use Cauchy-Schwarz. So using Cauchy-Schwarz, what you will get? You will get summation 1 by n square, n belongs to n, this to be half, and if you use n belongs to n, x in our product en to the power half. So by Cauchy-Schwarz. Right. Now as we know this series is 1 by n square is finite, so it will give some finite value. Let's see. And what is this term? So as x is given by this, so if you compute the norm of x, as ENs are orthogonal, so what you will get basically, so this is some constant c, and this will be the norm of x, right? Why? Let me write it here. So as x is given by x in our product en, and ENs are orthonormal, so norm of x square, it's given by n belongs to en x en mod square, as ens are orthogonal or orthonormal. So you have got mod of, so what we have got, mod of fx is less than equals to c times norm x, and so, and this is true for all x, right? So it is basically saying that for each x this is also finite, this is saying, means this is well defined, and it is saying that f is, this is same as saying that f is a bounded linear function, so which implies f is bounded linear functional on H. Okay, so we have, so therefore such a f exists, and what is, and if you put f of en, and what is f of en, if you put en here as f of x is given by summation n belongs to n 1 by n x n, so f of en will be n belongs to n 1 by n, so this is en comma, sorry, let me write it k ek, right? Because this, so I am writing is just k, the dummy index, and as ens or ekns are orthonormal basis, so this will be 1, so this is exactly, it will be 1 by n. Why? As inner product en and ek, so this is 0 if n not equals to k, and 1 if n equals to k, right? So therefore it will, this series will only remain when k equals to n, and for this it will be 1 by n. So therefore we have got such f should be f of en, it is given by 1 by n. Okay, so then which option is correct? So we have got that p is true and q is false. So p is true and q is false, so option b is the correct option. Okay.